To illustrate the binomial distribution in Minitab, we're going to look at the problem on slide 18 here of the discrete random variable notes. We are told in this problem that 80% of Canadian households have access to high-speed internet. That 80% represents our event probability, and that has to be expressed as a decimal, as I see here. And we're told that 20 households are selected at random, so sample size n is equal to 20. In the first part of the question, what is the probability that exactly 15 of these 20 households have access to high-speed internet? We are looking for probability that x is precisely equal to 15. In part B, what is the probability that at most 14? At most 14 means 14 or less, so less than or equal to 14, and for this we will use cumulative probability, as we'll see shortly. The next part of the problem is asking us for the probability that at least 17, which mathematically means 17 or more, and part D of the question, find the probability that between 16 and 19. So we want to know the probability that x will be less than or equal to 19, but greater than or equal to 16. Now going to Minitab, let me get situated here for a sec. So once we launch Minitab, we're going to go into the Calc tab. Second from the bottom says Probability Distributions, and we pick the binomial. In this problem, we are told that 20 households were picked at random, and we were told that 80% of them had access to high-speed internet. That goes in as a decimal. In the first part of the problem, we want to know the probability x is equal to 15, so change the radio button here to probability. And we're going to give the program a single number, in this case 15. Click OK, and we get our answer. So a couple of things to take note of. First of all, we are using the binomial. The sample size and the event probability are defined. The printout here says probability density function, and the word density function means it's the probability x is precisely equal to a certain value. So in our case, probability x is equal to 15 is the 0.1745 we see here. In the next part of the problem, and I'm just going to go to Edit Last Dialog Box, the question asked us for the probability of at most 14. So first of all, I'm going to change my constant here to be 14. And at most 14 means 14 or less. So anywhere between 0 to 14 of these households having access to high-speed internet. That means we got to change the radio button to cumulative probability. And here's the answer. And again, notice that this says cumulative, and it's the probability x is less than or equal to, and the answer here is the 0.195792. In part C of the problem, we want the probability that x is greater than or equal to 17. Now, Minitab will not do greater than or equal to, but we can convert greater than or equal to's to less than or equal to statements. We know that none of these households may have access to high-speed internet, or 1 or 2 or 3 or 4 or 5 or 6 or whatever, and it could be 15, it could be 16, 17, 18, 19, and 20. Excuse this mess, but this is the best I can do. Okay, we want 17 or more, but the program will not give us 17 or more. We could do equal to 17, equal to 18, equal to 19, equal to 20, sum all that, and get the answer. But there's a faster way to do it. The total probability over all possible values of x has to equal 1, always. We subtract from that the probability of the numbers we do not want. I do not want the probability of 16 or less. I'll get Minitab to give me that, and we'll subtract that number, whatever it is, from 1, and that will be our answer. Okay, so going to the last dialog box open, I want the probability of 16 or less. Make sure this says cumulative probability. Click OK. Here's the probability of 16 or less, which if you then take that number and subtract that value from 1, you will get the answer that you are looking for. And that's worked out on the next slide in your notes. Okay, in the last part of the problem, we are looking for the probability that somewhere between 16 and 19, so 16, 17, 18, or 19 households have access to high-speed internet. Again, one way we could answer the problem is to get the probability of exactly 16, 17, 18, 19, add those four probabilities together and get the answer. But the faster way to do it is to get the probability of 19 or less using cumulative probability, and from that subtract the probability of the numbers we do not want, and we will not want 15 or less. And we can speed this up a little bit. I could put both values that I'm interested in down in my spreadsheet. So I want probability of 15 and 19 or less. Going back to the last dialog box, this time rather than inputting one particular number, I could just give it column C3, which has the two values I want. This says cumulative. I click OK. And here's the probability of 19 or less, the probability of 15 or less, and if you subtract these two numbers, you will get the probability of the numbers that you do want.